Hey everybody, we are in section 2.6. The name of this section is Prove Statements About Segments and Angles. And I'm going to let you get started with your notes right away. Don't forget to put the date and let's go ahead. We only have about 5 terms, so in your packet there's a lot of space, my bad. But we're going to talk about each of these terms. So the first term that we're working with is the idea of proof, and that's what we're going to be talking about all this section. And what a proof is, it's a logical argument to prove a statement true, right? And so basically it's what we do in math to justify a rule or a law or some kind of relationship that we want to bring forth. And we're going to be doing that a lot in geometry. So the first word is proof. The next phrase or the next word that we're going to be thinking about is a 2-column proof. And so this is very much akin to the stuff we were doing when we were doing our Uno proofs. We would start off with a statement, which would be what card we're going to play next, and then a reason, which would be the justification as to why we can play that card. A theorem is very different from what we've talked about in reference to other rules in math. We talked about postulates a lot. In fact, you guys have a bunch of postulates and properties that you wrote down in the last 2 notes. Here, we're going to be talking about theorems. Theorems are rules, statements that we can prove and that we're going to be expected to prove. So we've got 2 theorems. Theorem 2.1 is about segments. So segment congruence is reflexive, symmetric, and transitive. If you remember those words from before, this will make perfect sense. So basically what we're saying is if you've got segments that are congruent, you can relate them in the following ways. So reflexively, we know that segment AB has to be congruent to itself. Segment AB is congruent to segment AB, and that would be a reflexive relationship. And symmetrically, we know that if segment AB is congruent to segment CD, then segment CD is congruent to segment AB, right? That's that symmetry relationship. You can kind of flip-flop those ideas or those equivalences or congruences. And then finally, we've got that transitive relationship. If segment AB is congruent to segment CD and CD is congruent to EF, then AB is congruent to EF. We've got that it's kind of like law of syllogism where you've got 3 things that are related and then the 2 end things are related. Okay, so that's what we know is true for congruence in segments. And honestly, guys, that's going to be true for your congruence when you're dealing with angles as well. So I want you to keep that in mind, that if you have in theorem 2.2, if you have angles that are congruent, they also relate in a reflexive, symmetric, and transitive way. So with that in mind, it's time for example 1. Go ahead and turn several pages to your examples. Sorry that I didn't do good with saving the trees on this one. Let's go ahead and look at example 1. We're about to write a 2-column proof, y'all. So you have this information here. We're going to look at the picture, look at the information, and see if we can mentally think through what exactly is being stated here. So the first thing we have is that we're given some information. Let's look at the picture and talk about it real quick. So given that angle 1 and angle 2 are both congruent, let me highlight those. I'm sorry, angle 1 and 3 are congruent. I'm going to highlight those so I can keep my attention on it. The next thing we're supposed to be figuring out is figuring out whether or not we can say the measure of angle EBA. Let's highlight that by tracing that angle, EBA. Notice EBA includes angle 3 and angle 2. We want to see if EBA is congruent to or is equal to angle DBC. And that's this one that I'm highlighting in or tracing in green. When you want to build this argument, what you need to do is first look at the picture and carefully see if you agree. So angle 1 and angle 2 makes up our green angle, and angle 3 and angle 2 makes up our red angle. I'm starting to think that they're equal for a couple of reasons. Take a look. They already contain equal parts and then we're adding to it the same thing. Let's go ahead and write this out so that it can make a little bit more sense. First thing we want to do when we start a proof is we want to, in general, not always, but in general, we want to write that first given statement. So let's start off with that. The measure of angle 1 is equal to the measure of angle 3, and our justification for that is that it's given. The next step, we're going to start bringing in this concept, including these angles. And I'm going to include it with the description that I just said before. Notice that the measure of angle EBA is really the same as angle 2 plus angle 3. So I'm going to write that down. And that, if you guys remember, is from the angle addition postulate. So that's from the angle addition postulate. And the next thing we can do is the same thing. We can describe the measure of angle DBC in the same way, recognizing that the measure of angle 2 plus the measure of angle 1, right? That's this green angle DBA. The measure of angle 2 plus the measure of angle 1 is equal to the measure of angle DBC, my bad. All right, and again, that's the angle addition postulate. So I'm going to just use ditto marks to say, yeah, same reasoning here. So now that I have that, I'm kind of interested in the fact that I can write this relationship out, and you guys will see why we're doing it. The measure of angle 2 plus the measure of angle 3 has to equal the measure of angle 2 plus the measure of angle 1. And this comes specifically from looking at this first line. This first line says that the measure of angle 1 is equal to the measure of angle 3. Down here, I still have 1 and 3 being equal to each other, but notice I've added something, the same thing, to both sides. There is a rule that gives us permission to do that, and it has nothing to do with any of the stuff going on in here. It has everything to do with the addition property of equality, right? So that addition property of equality stated, if you guys remember, if A is equal to B, then A plus C has to equal B plus C. Meaning, if I start off with two things that are equal and I add the same thing to both sides, that equality is maintained. So my point is that we now have the power to do what we've been wanting to do, which is to set these guys equal to each other. How, you might ask? I'm so glad you're asking. Let's look. I don't want to overstimulate you with too much highlights, but look at this. The measure of angle 2 plus the measure of angle 3 is also here, meaning that this is equal to this. So the measure of angle EBA can be placed here. Similarly, let's use a different color. If I see the measure of angle 2 plus the measure of angle 1, which I see here and there, I know that that's equal to the measure of angle DBC. So I can now, in this fifth step and final step, write that the measure of angle EBA is equal to the measure of angle DBC, because what I'm doing is substituting. So this is the substitution property of equality. And that's our first proof, all right? Hopefully that made a little bit of sense. Go over it, review it without having to write it down. I promise it'll make more sense that way. Here we are at example 2. It says name the property shown. Here's what I want you guys to look at. I want you to see that we're starting off with angle R, right? And we're going to have angle R in our final statement. We also say that angle R is congruent to angle T. And then we're saying that angle T is now congruent to some other angle, let's say angle P. Look at this relationship. R is congruent to T, T is congruent to P, and finally R is going to be congruent to P because of that relationship. So when you are dealing with something like this, I want you to immediately see the transitive nature here. So this is the transitive property of congruence. All right, so if you take a look at this second part, we've got segment NK being congruent to BD, and then BD being congruent to NK. I'm hoping I really have students who know what this one is. It's the symmetric property of congruence. Let's look at this next one. In example 3, we're going to use properties of equality. Okay, so we got another proof going on. We're starting off with a given, and we've got to prove a couple of things. First thing we want to prove is that this whole segment AB is equal to 2 times the shorter segment AM. And then we want to prove that AM is 1/2 of AB. And these are going to be really related. So if we can get to this guy, we can definitely get to the second one. So get started by drawing a line like this and giving me a column for statement and reason. Give yourself space and let's get started. So like generally, we're going to start off with our first statement being the initial statement, and we know that that statement is given. So we're going to write that M is the midpoint of AB on that first line. What we need to do next is kind of you notice how like this looks like an algebra problem in a way, like we're dealing with numbers. Remember when AB with no line on top and AM with no line on top really means the length of that segment. So what we need to do is get some kind of relationships here. The first thing we know is that segment AB segment AM has to be congruent to segment MB, right? Do y'all remember why that would be? AM is congruent to segment MB. I'm hoping you guys know, right? When we have a midpoint, the midpoint creates 2 congruent segments. So this is by definition of a midpoint. The next thing we're going to do is consider how we can change this to a numerical value. So right now, this is not a number. These are congruent segments, but we need numerical values to be equal, right? Congruence deal with shapes, but equality deals with numbers. So now I'm going to just say that AM, that means the length of segment AM, let me write them both capitalized. The length of segment AM has to be equal to the length of segment MB, and that's definition of congruence, right? Definition of congruent segments. That's where we got that from. And so now the next thing is we need to kind of think about how we can bring AB back into the mix. And so we can bring AB, the entire segment, back into the mix by looking at the fact that the segment AM, the length of AM plus the length of MB has to be equal to the length of AB. And so what that is the segment addition postulate. Okay, so now that we're here, it's starting to look like something to me. So if AM plus MB is equal to AB, and I know that AM is equal to MB, and remember, I'm trying to get this situation here. I'm trying to get 2 AMs equaling to 1 AB. I think I might have it. Because look, I can replace, right, substitute AM right here in for MB. So I'm going to use this for my line 5. Line 5 is going to be AM plus AM equals AB. Why can I say that? By substitution. Substitution property of equality. Okay, so now that I've got that, I can easily write this as 2 AMs is equal to AB, because I know that AM plus AM gives me 2 AMs. Why can I do that? That's again substitution property of equality. I know that AM plus AM is 2 AM, not 2 AM in the morning. Okay, I know that AM plus AM is 2 of those, and so therefore I can write that again as substitution property of equality. And I finished first part of this, right? I know it's kind of written in the opposite way. I guess I could switch it around. I could switch it around if you guys want me to. So AB is equal to 2 times AM. And what gives me the power to switch that around? Symmetric property of equality. I can do that. Gives me that little line there. And from there, could divide both sides by 2. If I were to do that, right, then instead of having AB over here, I'd have 1/2 of AB, and then instead of having 2 AMs over here, I'd just have AM. And that's what I wanted. I wanted AM is equal to 1/2 AB. But I know I got a student sitting up here saying, but it doesn't look the same. So let's see if we can make it look the same. First of all, this is the division property of equality. We can flip it around so it looks exactly like this part. And you guys know why we can do that, right? I can say instead that AM is equal to 1/2 AB, And that's the symmetric property of equality, because I can do that. Symmetric property of equality. Boom. And we're done. Second proof. We're doing good. I hope this made sense. Again, sometimes it might be easier to just look through the whole video before actually writing it down and then write it down as you go. I hope this made sense. Let me know if it didn't. You know your notes aren't done until you do this. Try these on your own. Name the property. They're not hard. You can do it. Don't show me notes without these done, or I'm going to say they're not done. All right, babies. I want y'all to have a good one. I look forward to seeing you soon. Let's talk. Take care. Bye-bye.